Thank you so much, gentlemen, for joining us today. And Rubaiyyaat, I hand over the reins of the session to you.
Thank you for inviting us to have this session. It's a very exciting topic. And with me today, we have two gentlemen, the Senthil, the head of Cloud and DevOps Architecture at Standarad Bank, and Lawrence from Snyk, head of Solution Engineering APG. I think three of us will have a very exciting discussion on this. So maybe Senthil, I will ask Senthil and Lawrence to introduce themselves and say a few things about them for the audience. So do we have Senthil on the line? Yeah.
Hi, Rubaiyyaat.
Maybe you can start. Yeah, thank you.
Hi, thanks for the introduction. I'm happy to be here, sharing some of our learnings from what we are doing at Standarad Bank. I've been with the bank for over 7 years and in the financial industry, especially working on ID for last couple of decades. I've spent about a decade in core banking solutions, and I worked on multiple solutions in consumer, private, as well as in corporate segments of banking. Last 3 years, predominantly my focus has been on cloud transformation for the bank and looking at cloud as an enabler and also making it mainstream for some of the core platforms and services within the bank. Happy to be here and be part of this fireside chat along with Lawrence and share some of our learnings. Thanks, Rubaiyyaat. Back to you.
Yeah, thank you. And Lawrence, maybe can you introduce yourself?
Yeah, sure, Rubaiyyaat. Hi, everyone. Nice to be here. Yeah, I look after the solution engineering team for Snyk in Asia Pacific. What does that mean? That is the sort of technical muscle behind the sales and the field team. So we're helping customers not only implement the technology, but make sure they're successful in their sort of DevSecOps journey. I've got teams sort of scattered across all of Asia Pacific. Prior to Snyk, I was at a company called Elastic, doing a very similar role there. Prior to that, a company called Pivotal, which was that spin-out company out of VMware, focusing on sort of cloud-native applications. Most of my career has been in sort of software and cloud. I've got a good mix of vendor and client-side, so in the trenches experience as well. So very excited here to share some of my experience and not only from what I've seen, but also working with my customers as well.
Thank you. I think we have a very exciting chat here. So, ladies and gentlemen, welcome to this fireside chat, Reimagine Security for Cloud Native. Wherever from the world you have joined, very good evening, good morning, or good afternoon. So, I think we are moving towards more cloud native application development from our traditional process, where I think in the previous session, we see that there is a shift left approach, and that's not enough. Now we want to integrate security and various stage of CI/CD pipeline. We want to have security right from the design, architecture, threat modeling, and then go on towards development and release. So more and more companies are accepting this cloud, adopting the cloud infrastructure and technologies to manage their application security. So I'd start with asking Senthil that, how do you address these concerns, or how do you manage your application security or cloud adoption in this, changing from traditional process to a more cloud-based or cloud adoption?
Okay, thanks for that. In the bank, we have a holistic cloud governance framework that looks at how we are moving things onto cloud in terms of regulatory aspects, in terms of data resiliency, in terms of risks, and in terms of cyber as well. So cyber is one of the key pillars in terms of the governance framework that we have put in the bank. Now, we have cybersecurity policies and processes in the bank, which we have revamped quite a bit based on the strategy to migrate onto cloud. While the set of controls and processes may not change so much from an on-prem, but we do see there are different types of threats that are emerging when it comes to cloud. Lawrence was talking about how application and infrastructure kind of merges together when you deploy things onto cloud. Now, there were times when developers were happy that I'm only going to do security testing and penetration testing for my code. and the infrastructure is provisioned by my infra team, and they take care of the underlying platform security. But that line has merged now, and now the onus is on each and every development team to look at security upfront. So we have adopted a principle of secure by design. That means anything that goes onto the cloud has to be secured by design. So that means starting from the first day when you are conceptualizing an idea of building a solution, you need to look at security, and it includes all the areas across infrastructure and application. So we have competencies within the bank which look after that, and there are the governance process also reviews it, and we rely hugely on automation as we adopt infrastructure as code and building secure pipelines. So these are things that we're doing.
Okay, thank you. Yeah, I think you've rightly pointed out that, previously we had just depended heavily on security testing before releasing, but now it's not that just one testing process. We want to engage security in every steps on the CI/CD pipeline. So I think Lawrence, he's have more experience and more familiarity with the various tools and cloud technologies used to manage these application security process. So maybe you can share that what are the new things, cool things coming up, and how different organizations can be benefited, using these technologies.
Yeah, it's an interesting question. A lot to unpack there, I guess. I think there's a couple of different angles. So one is the sort of technologies itself, things like Kubernetes, containers, infrastructure as code. These are all obviously fantastic technologies and helping companies innovate and go faster. But, who really understands the security implications of all those different pieces and moving parts, right? Developers aren't security experts, but they've been asked to actually deliver these assets in production now. So they've quickly got to learn how to secure those assets, and they need tools that are going to show them, where the problems are. But I think the problem with a lot of security tools these days, they're not focused on the developer. They're more focused on sort of the auditor sort of persona, where they may set up gates during the development process, in the pipeline to stop developers actually, importing vulnerabilities in the code in the first place. But that's going to get in the way of, a DevOps team who are going fast, who want to ship code multiple times a day. So I think there needs to be some checks and balances, and this has to be figured out within the team. What is acceptable risk, right? Obviously, we don't want, super critical vulnerabilities going to production, but there's a certain level of vulnerabilities that could be acceptable to go into prod, right? So what you need is a tool that helps you prioritize and triage these vulnerabilities correctly in the context of your application, not only your application during the coding stages, but also when it's in production. You want to bring as much sort of deployment context, how the application gets used, how it gets deployed, on what infrastructure, back into the development process to help developers actually prioritize and triage issues and focus on the ones that are more important to the business, right? So you can't just sort of code in isolation and then scan the code and say, oh, these issues are critical, these issues are high, these are medium. Go and fix that before you deploy it. Having the additional context brought in is going to help the developer actually figure out what's really a critical vulnerability and what should be fixed now, and prioritize accordingly. So, for example, you may have a critical vulnerability in your code and it gets released to production, but for whatever reason, that piece of code never gets executed by an end user. So therefore, the risk is quite minimal, right? But you have 10 other things that are executed by a end user that are only medium. But I would say that those are higher, have a potential of causing more damage than this critical one that is actually not accessible by users. So, having that sort of application context and the tool actually bringing that in and helping you triage and prioritize is really important, especially in today's cloud native world where you have microservices and multiple feature teams deploying to production at all different times of day, and they sort of own the responsibility of doing their own deployments. How do you keep control of all that stuff, right? So the tool's got to do a lot of that heavy lifting for them so they can stay secure but still go fast, if that makes sense.
Yeah, thank you. I think if I understood you correctly, so you highlighted very important 3 points. The number one is that we have to have a risk-based approach. I mean, the external risk rating may not be applicable for a in-house organization. So they have to come up with the approach that what is really my risk for this vulnerability, and just because a CV score is 8 or 9 does not mean it actually going to have same high risk impact for us. So they need that risk-based approach. And number two, they need to have a decision-making process, right? What I'm going to block and what I'm going to release. And if they have to do it manually, it will be actually kind of bottleneck. They have to wait for the security team to come to a decision. But if there is an automated tool that can actually have some rule and pattern recognition and give up some decision on behalf of the organization, that could help us then to ship the code faster, because we on, all of our organization is actually, we want to ship code as fast as possible, reach it to the market, reach to the end user. And finally, we need some tools that may guide us, like static code analysis, that okay, this code is not secure, try different approach, this library is not good. So these 3 things will actually really help the team.
Actually, there's a 4th one I failed to mention, which is auto remediation. A lot of the traditional security tools focus on the reporting and auditing side, but not the fixing side, right? The remediation. So that heavy lifting I talked about, where developers need not know, why this vulnerability exists or where in the code base, but like, let's just give me a pull request so I can go merge the code, merge the fix in, so I can get on with my job of building new features into the app, rather than sort of being bogged down with sifting through thousands of lines in a report to work out where the issues are.
Yeah, right. I think that's a very good point, because if otherwise it's just a backlogs keep piling up with a lot of findings and they don't have enough time to fix it over time. Yeah, that's a very good point. So automating the fixing is also very important. So I'll go back to Senthil. Since there is a transition from previous and traditional approach to this cloud-based, and a lot of traditional security or the traditional application is not really designed for cloud. So when you move there, what are the things you think that there is maybe gap or concerns you find from your experience, and our audience, who maybe wants to address the same gaps or concerns? What is your advice for them?
Yeah, for organizations that are moving from traditional on-premise infrastructure to cloud, they would already have a fleet of security solutions that they would have deployed in different domains. But most of the solutions would not be fit for purpose when it comes to cloud deployments. For example, how do we manage our certificates in on-prem? We have kind of a manual process of certificate provisioning. There's a certificate authority which issues certificates. Now, does that work in cloud? No, it doesn't, because you got to dynamically renew, revoke, and issue certificates on the fly for your container workloads, and you have to monitor where are the certs being used, etc. So that's one example. Secrets management is another example. Some of the in-house platform that we're using for secrets management doesn't really scale up on cloud. We move from more user-based identities to managed identities on cloud. So we've got to dynamically issue secrets and then monitor the usage of them. So things are slightly different, or I would say completely different in many of the areas. Monitoring is another example. We were using some platforms for our database monitoring, but when we went to cloud, some of these platforms won't support the cloud native database services that we are using. So we had to look at some of the streaming solution available within the cloud native platform for building monitoring of databases. So there are a lot of things which changes, and most of your tools would not be fit for purpose. So you will have to re-evaluate them and see the control that you want to implement on cloud. What are the right sets of tools that you will need?
So I have just one follow-up question. So, since this cloud adoption becomes very complicated than traditional, so how do you really measure that, the DevSecOps is going to the right direction, or the security posture is actually becoming mature or continuously being improved? What are the measurement steps, or how do you monitor that, that we're on track?
So we have 3 types of controls: detective, corrective, and preventive controls. So from the cybersecurity policy, we derive controls. We have in the bank over 800 plus controls that are derived out of that. And this is a continuous thing. It keeps emerging as new threats come up. The modeling needs to happen, and the controls should continuously be improved. But broadly on these controls are into three categories: preventive, detective, and corrective. So the preventive controls are the ones which we not allow developers to do things. For example, the console for the cloud is completely read-only. That means developers cannot go and do any changes onto the infrastructure. So that's the kind of preventive measure. We secure the baseline of how an account is provisioned with a lot of security control. That's a preventive. Developers cannot go and change that. But we also have corrective and detective controls. So we are also monitoring continuously the infrastructure, and that is feeding information back into our cyber defense center. And that's where we get insights of what's happening, and our controls will be monitored as well as improved upon. And there are also some corrective measures that we take. For example, if you get an alert for certain action, then we already have a fix for that, which we would immediately trigger. For example, an access to the S3 repository is not expected for, then there would be a Lambda code which will trigger as a corrective control and go and fix that vulnerability or go and fix that configuration issue, etc. So that's how we do it.
Thank you. Yeah, I think the access management and change management is the key, and also how much asset you want to expose to the outside world. So Lawrence, what do you think the organization who's newly moving from on-premise to cloud, what is your advice for them to know so they can really become mature over time or measure their continuous improvement so they know that they're actually improving the security over time?
Yeah, it's a beast of a topic. We may open a can of worms here, but because I don't think there's any one answer or silver bullet. It depends on the context of each organization. But from what I've seen is, don't start with the KPIs, right? From a top-down approach, because what happens is the team end up chasing numbers, and they may be the wrong numbers. So you may end up going down the wrong path. Instead, have sort of a bottom-up approach, right? Where have a look at your security posture today and try and figure out what data points you have, and even correlate some together to make sense of the health of or the risk associated with those metrics in the context of the application. You can't just sort of have isolated standalone metrics like the number of vulnerabilities, because it depends on the context of the organization and the team as well. For example, you may have one team that has 400 vulnerabilities and team 2 has 20 vulnerabilities. To a novice person, they may say, oh, good job, team 2, you've only got 20 vulnerabilities. But when you sort of dig into it a bit further, team 2 may not have the same testing coverage as team 1, right? They may not have plugged themselves into CI/CD pipeline at other stages of the development lifecycle, and then therefore missing a bunch of critical vulnerabilities. That's number one. Number two, not all vulnerabilities are equal, right? Like the team A could have 400 low or medium vulnerabilities, which the business could accept to be deployed to production. But in teams 2's case, they may have 1 or 2 supercritical vulnerabilities that is going to bring the whole site down, right? So those 1 or 2 critical vulnerabilities are worse than those 400 vulnerabilities. So you really got to sort of assess this in the context of the teams. Another example is what team A may actually have pretty good security posture, right? And they're scanning in all the right places, but they're actually doing lots of feature development in the last couple of sprints, right? They're doing a huge amount of refactoring or addressing a lot of technical debt, as well as introducing new features. So there's a lot of commits happening in the repository. So the average law says that the more commits you have, the more vulnerabilities you have, right? If you're downloading open source libraries, etc., and obviously the proprietary code as well. So you've got to take that into account as well. So I think you need to sort of correlate metrics together. And some are sort of the driving forces of the others. Like I said, more commits, more vulnerabilities. Another example would be, the average time to remediation is going to be smaller for critical vulnerabilities because the business has a certain SLA of fixing those versus the low and medium vulnerabilities where the average time to fix is going to be longer, right? So you can't just look at average time to fix across the whole team. You need to do it in the context of certain vulnerabilities, whether they're critical or low. And I think ultimately what you want to do is bubble up a lot of these metrics into a high level measurement like application risk score, which is what sort of upper management want, right? They want to be able to see, is my application green, amber, or red, right? To see if there's a risk factor associated with application, rather than having like thousands of metrics and executives trying to figure all that stuff out. Do the work to sort of correlate and aggregate these together to give you those higher level metrics. Does that make sense?
Yeah, I think you brought a very important point that, most often we look into just number of vulnerability, open vulnerability, but that may be sometimes misleading due to the test coverage, how many times it is tested. Because if the team is actually detecting earlier phase of a development, that's better than the team who is detecting much later, because then time to fix may vary. And also the time to remediate, right? We should fix the critical and high first, and then so that we have the right balance of allocating the resource for that. So I think we don't have any questions so far. Okay, so I'll ask one question to Senthil. I think so. As you mentioned that you are automating a lot of infrastructure as a code or pipeline as a code. So, and also I think containerization is also a new issue. A lot of people are using containers. So, how do you think then to address the security in this automation and containerization? What should be the best approach, and also balance between ship code fast and also avoid manual intervention?
I mean, it really depends on the context. For example, from a bank perspective, for us, everything needs to be quite secure. Of course, the risk ratings would vary in terms of the type of data and things that are there. For us, the data classification plays an important role in terms of looking at what sort of risks that we have. Certain applications or workload which might use public data or internal data are okay to have certain controls not fully implemented, but things which are confidential, restricted, needs to have the highest level of security. So you need to have. So it really depends on each organization and what their current security posture is and how they want to, and what are the emerging threats for them, what threats are happening in their industry, and based on that, they would have to make those choices.
Okay, thank you. So I think we are almost end of the time. So Lawrence, do you have any concluding remarks, like top three, best 3 tips for our audience who is going to adopt Crowther and also focusing on application security?
Yeah, I mean, I would start small. If you sort of force the developers to start using all these tools across the whole life cycle, I don't think it's going to go so well. So, introduce them at various milestones. Maybe start. Probably the easiest low-hanging fruit is the what's called SCA or software composition analysis, where you can scan what open source libraries you have in your applications and therefore what vulnerabilities lie within that. That's going to probably give you the biggest bang for buck. If you're using things like containers, you've got the Docker file potentially that developers use to build the containers. You can scan that, but you can also scan container images that are deployed to like container registries or a Kubernetes cluster, for example. You really want to scan it in 2 places, because scanning from source is fine, but you may miss stuff because the dynamic nature of creating container images, they may download other software that's not defined in the Docker file, or if you're pulling down images from say Docker Hub, they may change. So you really want to scan the actual image that you create for containers, and then infrastructure as code. If you're just starting out with like a Terraform, you probably haven't sort of codified all of your assets that you're running in the cloud. So there are tools to actually point at AWS, let's say, and then sort of reverse engineer the Terraform file from what you have. So that's a good starting point. Obviously, beware of some of the default settings. You want to make sure that's locked down, but of course you can use a tool like Snyk to actually scan that file to see potential issues that you have, and you can fix them before you go ahead and sort of, apply the Terraform configuration back on top of the cloud. And then I think we were talking to Senthil before, in his organization, he's locked down the AWS console, make it read-only, so that once you've codified all the infrastructure in infrastructure as code, you don't want people to go in and inadvertently change stuff manually on the console or, through applications or what have you. If they need to change stuff, they go back into the source files, and then it gets deployed through the CI/CD pipelines back out into the code. That way you can obviously have more controls over it, and therefore the security of it as well. Would you agree, Senthil?
Thank you, Senthil. So I think we're running out of time. So let me conclude. So what I've understood is that, we have been, if you have been more time to discuss, it would be nice, but since we don't have time, so if a new organization wants to adopt cloud-based application security, I think the first thing they have to do is that, they have to start slow. They cannot install and tools everywhere immediately. So they have to start from the developer, guide them with some tools so they can identify what are the vulnerabilities, what are the vulnerability in the open source codes, and then add more sensors and more scanning tools and testing tools automated that can be added in various stages of the life cycle, containers, build cycle, and release cycle. So that can, and we also need a good risk-based decision-making process so that, we understood what is my risk and which one I should block, which one I should allow. And then we need a very good change management and access control so that, the assets we have in the cloud can be managed well. So I think that's a very good discussion. So unfortunately, we don't have time to take a question right now. So thank you very much. I'll give it back to host and thank you, everyone. Thanks a lot.
Thanks, folks. Appreciate it. Cheers.